Give an example of a degree 5 polynomial with precisely 3 distinct x-intercepts. Okay. So this actually seems really difficult, but it's not too hard at the end of the day, and it depends really on a bunch of algebra how difficult you want to make this. So let's try and set it up with, let's have the x-intercepts. So I'm going to kind of work backwards. Let's have the x-intercepts be, I don't know, 0, 1, and -1. I like that, right? So what does this mean? Well, I have to have a factor of x in there, a factor of x plus 1, and a factor of x minus 1, if I'm going to get these. And I don't want any more than this. But the problem is the product of these is degree 3, which is no good. So how can I get around this? Well, I could just bump up some of the number of times these occur. So the simplest thing you could do would just be to raise this to the power 3. If you do that, you're good, because it's now going to become degree 5. In fact, you could easily, it's the difference of 2 squares. You don't really need to do this. Writing in a factored form is perfectly reasonable, but you could write it like this, 5 minus x to the 3. That guy there has exactly 3 distinct roots, because the only factors really are x, x plus 1, and x minus 1. And the 0 is repeated 3 times. Doesn't matter.